All right, welcome back. We're going to continue this video and do these last few problems for 3.4. So what I've got here is I want to list all the possible rational zeros of this function, okay? So remember, I want to take the factors of my last number and divide them by the factors of my leading coefficient. So here's what I got. All right, my factors, so factors of 6 divided by factors of 1. All right, so what I've got here, my factors of 6 would be 1, 2, 3, and 6. Now my factors of 1 is just going to be 1. All right, so what I would have is I would have plus or minus all of these numbers over 1. Okay, and so if you could leave it like that, but what I would what you can do is do this. You can do 1 divided by 1, which gives us plus or minus 1. You can do 2 divided by 1, which is plus or minus 2. Okay. You can do 3 divided by 1, which is plus or minus 3. And then you can do 6 divided by 1, which is plus or minus 6. Okay. And so these are my possible, rational zeros. Okay. So these are possible values where the graph is going to cross the x-axis, okay? So let's now take a look over here. Now on this one, it asks us to find all the zeros of this function. Now what we could do is we could list off all of the possible zeros and, go that route and use, and here's the deal, all right? Even on this one, if I were to find all the zeros on this first one, I would need to do synthetic division on 1, 2, 3, 4, positive and negative, so a total of 8 numbers to try and see which one of those is a 0, okay? That is a waste of time, all right? So what I want to do, in order to find all the zeros of this function, I'm just going to graph it real quick to get, to see where the graph crosses the x-axis so that I can know at least where to start. So let me graph this real quick in Desmos, and let me paste it in here, and we'll see what we can get. Okay, and so I've graphed this, and what this does, this one's pretty nice because it actually gives us all of them. So what we do is we know what we need to do in order, we know what the answers are going to be, okay? We know that our zeros are going to be x equals negative 5, okay, we know that x is going to equal negative 4, and we know that x is going to equal positive 1. Okay. Now, what I want to do is do the algebra that's involved. Okay, and it's really not that bad. Okay, but what we want to do is use synthetic division. Now, because I know all 3 of these numbers, okay, and they're nice and neat numbers, we can do synthetic division on any of them. The easiest one to do, in my opinion, is 1. Okay, so let's use 1 as our divisor. Okay, so here's what I got. I'm going to put in my coefficients here. I got 1, 8, 11, and then negative 20. So I'm going to drop down my 1. 1 times 1 is 1. 8 plus 1 is 9. 1 times 9 is 9. 9 plus 11 is positive 20. So then 1 times 20 gives me positive 20. Negative 20 plus 20 gives me a remainder of 0. So what I have done is this. All right, I have taken this this function, all right, f of x is equal to x cubed plus 8x squared plus 11x minus 20. And I have factored this, okay? And I have turned this into, now here's what I got. If x is equal to 1, if that's my 0, okay? So if x equals 1 is my 0, okay? My factor is going to be x minus 1, all right? So it's just the opposite of what we got. So what I've done is I've factored out an x minus 1, and here's what we're left with. We're left with x squared, all right? And I'm getting this from our divisor down here. This is x squared plus 9x plus 20. So this becomes x squared plus 9x plus 20, all right? This is what I've done. I have taken my original function and I have used synthetic division to factor out an x plus 1, or an x minus 1, sorry. Okay, and what we're going to do now that I have factored this out, I have a quadratic that I can factor, okay? And so, x squared plus 9x plus 20, two numbers that multiply to 20, but add to 9 is 4 and 5. So this is pretty easy to factor, and so I get x minus 1 times x plus 4 times x plus 5, okay? This is the exact same thing as this. The only difference is that this one is factored, okay? And it was pretty easy to factor, all right? So now if I want to find all my zeros, okay, I set these equal to 0, okay, x minus 1, x plus 4, x plus 5. All right, I'm going to set each of my factors equal to 0, all right? X plus 4 equals 0. X plus 5 is equal to 0, so I'm going to add 1 to both sides. So I get that x is equal to positive 1. I'm going to subtract 4 from both sides, so I get x is equal to negative 4. Subtract 5 from both sides, and so I get that x is equal to negative 5. So now, here are my zeros, okay? And they're the same zeros that we found over here on the graph, okay? And so it's really not too bad, all right? So, got to graph it first, at least get a starting point, okay? Because I could have, using the possible zeros, I could have tried so many. I would have done long division on all those numbers before I get to a remainder of 0, okay? Only 3 of those are going to work out of a possibility of, gosh, I think that would have been 10 numbers, 12 numbers or something like that we would have tried for possible zeros. So, all right, so that's that, okay? And let's just write those down, all right? Write down, we have our zeros, okay? And that's going to be that x equals negative 1. I'm sorry, x equals 1, x equals negative 4, and x equals negative 5. And those are my zeros, all right? Okay, now let's take a look at the next one. We want to find all the zeros of this function. So same thing is going to happen. And when you see something like this, you want to try and factor it, but you can't factor this by grouping, okay? So you can't factor it in that normal method. So we have to use another method, and that's going to be synthetic division. So let's graph this real quick and then see what we can come up with. Okay, so on this one, and I'm going to move this over so I got some room. What I know on this one is that when I graph this, these two zeros aren't what we call user-friendly, okay? But this one is, okay? So 2 is going to become, x equals 2 becomes my starting point, all right? So this is going to at least get me started with synthetic division because I'm unable to use these decimals, okay? Because they're not nice and neat numbers. They usually round these numbers, so it's actually not going to work if we try to use those. Okay, so we got to use 2. All right, so let's do this. All right, so I'm going to do 2. You have that as my divisor. Okay, and then I'm going to do 1, 1, negative 5, and negative 2. Okay, I'm going to drop down my 1. So I get 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 5 plus 6 gives us negative 1. 2 times negative 1 is going to give us, or no, this is just going to be positive 1, sorry. 2 times 1 is going to give me 2, and we get a remainder of 0. Do you see how I caught myself there? I realized that I was going to get negative 2 over here, and that wouldn't have added to 0. Yet I know that 2 is a 0. So I made a mistake somewhere, okay? Again, I just make errors where I write down the wrong sign, all right? So, so that's that, okay? And so now what I have is this, all right? I have taken f of x, okay, and I have factored this. And if x equals 2 is my 0, then my factor, okay, this is my 0, my factor is going to be x minus 2. All right, so that's my first factor, x minus 2. And then we have our our quotient, which was x squared plus 3x plus 1. Now, based off of our graph, okay, this tells me that I can't factor this evenly. Okay, if I'm getting numbers like these decimals, then this tells me that I can't factor this. Okay, and 2 numbers that multiply to 1 and add to 3, well, it doesn't really work. Okay. So if I don't have those, okay, then what I need to do, if I can't factor, all right, I need to use the quadratic formula. So if you can't factor, okay, then use the quadratic formula. Okay, so here's what I got. X is equal to, in here I've got A equals, sorry, I'm writing all over the place. A equals 1, B equals 3, C equals 1. So X equals opposite B. So minus 3 plus or minus the square root of 3 squared minus 4 times 1 all over 2A. So 2 times 1. Okay, so here's what we're going to get. X is equal to negative 3 plus or minus the square root of 9 minus 4. Okay, 4 times 1 is 4. Over 2 times 1, which is 2. All right, so I get X is equal to negative 3 plus or minus the square root of 5 over 2. Okay, I can't evaluate the square root of 5. Okay, so here are my other zeros. Okay, and all we're doing is solving for X. So I've got this. I've got X is equal to negative 3 plus the square root of 5 over 2. I have X is equal to negative 3 minus the square root of 5 over 2. And then I've got that X is equal to 2. Okay, so these values here are my zeros. All right, and that's what, and that's how we find that. Okay, so same thing, you know, when you get down to a quadratic, either you can factor this, okay, you know, think about what we had up here. This was factorable, okay, notice how we had nice, neat numbers over here on this graph. This one was not factorable, so if you can't factor it, you want to use the quadratic formula to find your other zeros, okay? And if we evaluated those, then it would give us these, you know, decimals over here. Okay, now this one, all right, we want to solve this equation. Okay, now this one kind of sucks. I'm going to be honest with you. The reason why is because you have a degree of 4, okay? So you have x to the fourth minus 6x cubed plus 22x squared minus 30x plus 13 equals 0. So, first things first, I want you to notice something. I want you to notice what we had here. When I had something x cubed, notice how we had 3 zeros. Same thing with this one. I had x cubed here. I had 3 zeros. I'm going to have 4 zeros down on this one, okay? My largest exponent tells me how many solutions I'm going to have. So because this is x to the fourth, that's going to give me 4 zeros. All right, so first things first, again, I could do the list of possible zeros, and it wouldn't be too bad. It'd just be 13 or 1, which we'll probably end up just using those numbers. But let's graph this, see where it crosses the x-axis so that we can go through and try and figure out what the zeros are. Okay, so over here, when I graph this, I saw something interesting here, okay? I have x equals 1 as my 0, okay? But I want you to notice something. Notice what happens at this 0. Notice how this bounces. All right, notice how there's a bounce. It bounces off. Bounces at x equals 1. Okay, this means that the multiplicity is going to be even. Okay, so what that means is that we may use this, so we can use x equals 1 more than once. Okay, and the other examples, all those zeros, they just cross through. Okay, but I want to show you, what this is. So just trust me on this. All right, just go ahead and let's work on it. So here's my 0. I'm going to do 1. I'm going to do synthetic division, okay, on this. All right, and so here's what we're going to get. Coefficient of 1, negative 6, 22, negative 30, and then 13, okay? So drop down my 1. So 1 times 1 is 1. Negative 6 plus 1 is negative 5, okay? 1 times negative 5 gives me negative 5. 22 minus 5 gives me positive 17. 1 times 17 is positive 17. Negative 30 plus 17 gives me negative 13. 1 times negative 13 gives me negative 13, and that's going to give me 0. Okay, so let's just talk real quick about what is going on here. Okay, I have taken x to the fourth minus 6x cubed plus 22x squared minus 30x plus 13 equals 0. And what I have done is I have taken out an x minus 1 factor, okay? And what that leaves me with is x cubed minus 5x squared plus 17 minus 13 equals 0. So I've done one little part of factoring, okay? Now, you have to realize that because I had x to the 4th originally, I divide out an x minus 1, I have x cubed. I still can't factor this, okay? So what I have to do is do synthetic division again to factor this down, okay? We're like at the previous two problems, okay, at this step. So now, remember what I had. Remember how this graph only crossed at 1, okay? It didn't cross at any other point. So I want to use x equals 1 again because of the multiplicity, okay? Because it bounced off at 1, that means that I have another factor of 1, okay? So let's do this again. And I'm going to do synthetic division on this part here. So I'm going to do synthetic division here. 1 is my divisor. Okay, and I've got 1, negative 5, 17, and negative 13. So drop down the 1. 1 times 1 gives me 1. Negative 5 plus 1 gives me negative 4. 1 times negative 4 gives me negative 4. 17 minus 4 gives me positive 13. 1 times 13 gives me 13. And add those together, we get a remainder of 0. Okay, so this works. Now, look what we've done. Okay, I have taken this. Let me zoom out a little bit. Okay, I have taken this polynomial, x to the 3rd, and I have separated it out into another set of factors. So here's what I got. I got x minus 1 times x minus 1, okay, times x squared minus 4x plus 13 is equal to 0, okay? And that's what I've done. Now I have something that's a quadratic. Okay, so now here's what I got. This quadratic can't be factored, okay? Two numbers that multiply to 13 would be 1 and 13, and adding to negative 4, we can't do that, all right? So in order to solve this, okay, we need to do the quadratic formula. So I'm going to do A is equal to 1, B equals negative 4, and C is equal to positive 13. So x equals opposite B, so positive 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 13 all over 2 times 1. Okay, now at this point, all right, so I've got x is equal to 4 plus or minus the square root. This is going to give me 16 minus 4 times 13. What's that? I think that is 52. 4 times 13 is 52. So 16 minus 52. All over 2. Okay, so x is going to equal 4 plus or minus the square root. 16 minus 52 gives me negative 36, okay, over 2. Now we get a negative number under our square root. This is going to give me an imaginary number. So my answer is going to be 4 plus or minus 6i. The square root of 36 is 6, but because it's negative, we have to account for that with an imaginary number over 2. So now, here's what I got. I got x is equal to 4 over 2 plus or minus 6i over 2. So x is going to equal 2 plus or minus 3i. Okay, and that's my answer. So, here's what I got. I do have 4 answers. Okay, for my zeros, okay, I've got x is equal to 1, x equals 1, x equals 2 plus 3i, and then I've got x equals 2 minus 3i. Okay, and that's what I have. All right, so that's how we solve that. Now, you don't have to write this twice. You can, okay, but you need to understand the multiplicity of that is 2, okay, and that's how we have 4 of those, okay, 4 solutions to this. At 1 works twice, okay. But this is why, okay, when we look at our graph, that we can't do that. You know, you can't look at the graph and get these answers. Same thing up here, okay. So, yes, guys, this is a lot of work, okay. However, you know, it is, I'm not doing anything different, Okay, I'm using synthetic division. There is a process here and an understanding. So it is a lot of work to get there, but it is doable. So let's get started on the homework and the rest of the problems, and we'll see you in a bit. Thanks a lot. Bye!